Hello, good morning. Welcome back to your Bridging Mathematics. Okay, so we are still on your module 1. We are still discussing the algebraic concepts. Okay, so before we discussed about your unit 1 and unit 2. That includes your recall on integers, fractions, and recall of integers, fractions, and index laws. And so you discussed there your operations on polynomials. Okay, so we are going to make use of those to discuss your unit 3. Okay, in this unit 3 you will be discussing your solutions on linear equation. Okay, so this is the unit learning outcome for this unit 3. Okay, so first is for you to solve linear equations using substitution, and then for you to solve linear equations using the other method, which is elimination. Okay, so first, what is linear equation? So if you say linear equation, okay, those are the first degree equations. We call that one as linear since if you are going to graph those ones, okay, those are just straight lines. For example, this one, okay, x minus 2 equals 4, that is this block, okay, that is just a straight line, inclined straight line. X equals 3, okay, that is also a straight line which is passing at x equals 3, so that is a vertical. Okay, so x equals a number is just a line vertical passing at that x. Okay, and this is y equals negative 1, that is also a straight line, okay, which is passing at y equals negative 1, so that is just a straight line. If you say y equals a number, that is also just a horizontal line. And we have here x plus y minus 2 equals 0. That is also an inclined line, which is this red one. Okay, so those are lines. Okay, if we say linear equation again, those are just equations of lines. So you will expect that those are first degree. By the way, if you say first degree, in all of the terms, you will only have there one exponent or one variable with one exponent. Okay, and then let's try to solve now your linear equations. If we say solve, we are going to solve the values of the variables. We will be considering those variables as the unknowns. Okay, so first, before we will go there, let's first try to understand what is system of linear equation. Okay, if you say system of linear equation, that is a group of independent linear equations. So there are linear equations which are grouped together, and we call that one the system of linear equations. Okay, so in solving the values of a system of linear equation, that the number of unknowns, or that is the number of the variables, should always be equal to the number of equations in the system. So you should not forget about this. Okay, so let's say there n is the number of unknowns in the system. If we say system, we are considering the group. So what you're going to do is count the number of variables. How many variables are there? Let's say there's only x and y, therefore there are only 2 in all of the equations. Okay, let's say there are x, y, and z. There are 3 in all of the equations. Okay, I will explain you that one further later on. And of course, your r there is your number of equations in the system. Okay, number of individual or independent linear equations in your group. And that number of linear equations should be equal to the number of the unknown on the system, so that you can solve this linear equation system. Okay, because if let's say n, the number of unknowns, is greater than that number of equation, you cannot solve that one. Even if you will try to be manipulating all of these equations, you cannot solve any of that. How about if that is the other way? Let's say your number of equation in the system is more than your number of unknowns. You can solve that one, but there will be a lot of answers, so your answer will be inconsistent. Okay, so if you are referring to a definite or specific answers or specific solutions, you should have their number of unknowns should equal number of equation in the system. Okay, so let's start. Okay, as I've said a while ago, you will be learning how to solve using the method substitution and the other one elimination. So first, your substitution. Okay, so in substitution, we are going to express a certain variable in terms of the other and substitute to the other equation or to the next equation. So for example, look at this example number 1. Okay, solve for the values of t and s. So in the first place, it is stated there that there are two unknowns. So or by merely looking, this is the system, a group of two equations, a group of two linear equations. It is a system of linear equation. And in the system, okay, if you try to look here, how many variables are there? T. Okay, it doesn't matter where that variable is. It could be in all of the equations or it could be only in one equation as long as that is in your system. Okay, so first is you have their t and then you have your s. So you have two variables, therefore you should have two equations also for you to solve those two values, and which is we have that one. Okay, we have the two equations. So we have the unknowns, two unknowns. We have two equations, therefore we can solve the system of linear equation. Okay, so solution. Okay, it says there express one variable, express a certain variable. So it's up for you to choose. Okay, which variable you want to separate. If you say express, you are going to separate that one on the other side of the equal sign. So by merely looking at that, okay, by merely looking at the equation, be wise in choosing this one. Actually, you can choose any, but there are other variables that if you will express on that one, it will make your equation complicated, but the answer will still be the same. Okay, so if I were you, I will choose here S. So where is that s which is separated, or which is s alone? That is in your equation number 2. So what will I do from equation number 2? I will express s in terms of t. So it means I will separate here your s since that is just s only. You can do that here on your equation 1, but if you will separate s there, if you will put that on the other side, you need to divide that one by this constant 3 for you to express your s completely. Okay, so for me, I'd rather choose your equation 2. I'd rather choose your equation 2. So I will separate that one. So uh, 2t will either go on the other side or s will go there. But if I will put there s, that will become negative. So later on, I need to multiply by negative to make it s only. So I'd rather transfer your negative 2t on the other side. So you have here your s equals negative 2t plus 1. That is still equation 2. Okay, but for us to differentiate these two equations, which is two forms of equation 2, I will put there 2a. Okay, that means that that equation is still equation 2, but it is in the other form. Okay, so that is our new form of equation number 2. So now I have here your s. Okay, that's why we call this one substitution, because okay, I will be substituting that equation 2a in your equation 1. Use now the other equation. Do not substitute it back to itself because that will just cancel out. Okay, substitute that one to the other or to the next equation. It says there, to the other or to the next equation. So that is what I will do. I will substitute that equation 2a in your equation 1. So if I will do that, the s in your equation 1 will become negative 2t plus 1. Okay, so here 2t is still 2t. 3 times s instead of s, that will now be changing to negative 2t plus 1. So that is, please enclose that one since that is more than one term. Okay, and that is still equal to 7. Okay, so as you can see, this is now a single variable, isn't it? So if we will try to combine all of those, you will only have there one variable. So actually, you can solve that single variable right away. Since if your unknown is one variable, all you need to do is all you need to have is single equation, and that is what we have here. You have there your single equation which has a single variable which is t. So if I will manipulate this one, okay, distribute your 3 to your negative 2t, and then 1, that will become negative 6t and 3. Okay, combine similar terms. So 2t and 6t will combine, that is minus, so that will be negative for t. 3 will go on the other side as negative, so that will be 7 minus 3. Now that will be equal to 4, but I need to solve t. I want to get the value of t, so I do not need that negative 4. So I will do is divide both sides. Okay, divide both sides by negative 4. So if I will do that, negative 4 and negative 4 cancels here on this side, but that will be a negative 4 here, and that 7 minus 3 is positive 4, isn't it? And that is divided by your negative 4. Again, what you do on the other side, you need to do that also on the other side of the equal sign. Okay, that is the rule of algebra. Okay, so that will be, okay, negative 4 will be positive 1, so that is just t. 4 divided by negative 4 is negative 1. So you have your value of t, which is negative 1, whatever that is. Okay, the value is negative 1. Now, what else? You need to solve the other, not just the first one. You need to solve also the rest. Let's say there are 3, then you need to solve 2 more. But since that is 2, you need to solve 1 more. So where will I solve that one? Now that is the time you will go back to the equations. You can make use actually of equation 1. You can make use of equation 2. Or you can make use of the other form of equation 2. So it's up to you. It depends. Those will always be possible because this is a system. If you say system, they work as one. And you have their t. How did we solve t? That is coming from the system. Okay, we used all the equations from the system to come up with that value. So even if you will use any of that equation of the system, that will always be the same. So now, for me to solve s, of course, be wise also in choosing. For me, I'd rather use s equation 2a. Why? Because s is already there, separated. All I need to do is substitute your t in that one, and you will have your s. Okay, so I will, okay, that should be equation 2a. Okay, so let me just edit that one equation. Okay, so I just changed that one to equation 2a. Okay, so again, be wise in choosing. If you will try to go back, s is already separated there, which is what we are trying to solve. And you have there t, so it is better to use equation 2a. So if I will use equation 2a, okay, it is rearranged again. Okay, so it's equation 2a. Substitute your equation, your t equals negative 1. Since you already know that one, substitute that, so t will just become negative 1. So manipulating this one, negative 2, negative 1 will be positive 2. Okay, sorry. Okay, so that's it. Negative 1, negative 2 will be positive 2, plus 1 will be positive 3. So we already know your value of t and s, but that is not enough. Okay, if you are sure, then no problem. But if you are not that sure, it is always best for you to check that one. How are you going to check? You can choose any of the equation. Okay, you can choose any of the equation, substitute back your s and t. If that will make it true, then that is correct. Okay, for example, okay, let's say I will choose equation 1. So prime equation 1, I will substitute there t, which is negative 1, and then s, which is 3. Okay, so t will be negative 1, s is 3. If I will now manipulate that one, that will be 9, that will be negative 2. So if I will combine that one, that will be 7. 7 is equal to 7. Is that correct? Yes, it satisfies the equation. So, okay, the answers are correct. If you are not sure, again, if you still doubt that one, you can make use of all of that one. You can check in all of the equation. But again, you can also make use of only one only, since again that is a system. The values you solve that one from the system. So if you, even if you will choose there any of the equation in the system, that will still be correct. But if you are not sure, if you are the, what we call this one, doubting type, so you need to check all of that, no problem. Okay, it's up to you. But you can only do it once. Okay, so let's say you still doubt. So you need to check equation 2. So I will do that. Equation 2. So substitute t as negative 1 and then s as positive 3. So that will be negative 2 plus 3. Negative 2 plus 3. Is that one? Yes. So we are 100% sure that our answer is correct. T is negative 1 and s is positive 3. Okay, so that is substitution. Let's have one more. Okay, so solve the values of x, y, and z. It means there are 3 unknowns, so there should be 3 equations in the system. Yes. So you have equation 1, 2, and equation 3. So what will I do? Choose again. Choose equation wherein you are going to bring out or express single variable. So it's up to you. So which one? You can actually, okay, be wise again. You can actually say I will use equation 1, or you can say I will use equation 2. But okay, you will, if you are get use of this, then you will decide better. But okay, let's say I will make use equation 1. Why? Because z is there separated. You can also make use of x equation 2 here. But again, the reason why I am choosing equation 1 is that, okay, if I will separate z, I will substitute that one in equation 2, then z will be out of the system already. So you will reduce your unknowns to 2 only, isn't it? That is our target. We are trying to reduce the unknown on the system for us to reach your single variable. Okay, for us only to have there one unknown, for us to solve that one unknown and then go back to solve the others, isn't it? That is what we are trying to do. So again, if you try to make use of equation 1, that is my target here. I will separate z, substitute that in equation 2, then everything will be xy, and here is just xy. So that's good. You reduced it to 2. Okay, so that is what I'm doing here. Express your z from equation 1 in terms of x and y. So z, I will separate z. This will go on the other side to be positive. 3 will go together on the other side to make it negative. And I can play around with that. I can interchange them. Okay, so z will go positive, separated, and then 3 will go on the other side together with this, but it will become negative. Okay, so let's say that is equation 1a, since that is just coming from your equation 1. Now substitute that equation 1a in your equation 2. So z will become this trinomial. Okay, so if I will substitute that, x plus 2y will still be the same, but 4 will be multiplied by this quantity on top. And that is still equivalent to negative 2. So x plus 2y plus 4, okay, multiplies, distribute. 4 times 6 is 24x, that will be 16y, that will be negative 12. Okay, combine similar terms. X plus 24 is 25, 2y plus 16 is 18y, and then actually I can put this negative 2 on the other side, it will become positive 2. This negative 12 will become negative 10. So we have a new equation that is not just coming from any of this. So it is a combination. So that is actually a real new equation. So let's call it as equation 4. 1, 2, 3. So let's say equation 4. So you have now your equation 4, and actually the other equation wherein they are now both x and y equations. So we can make use of this x and y, two x and y equations, okay, to solve this x and y. So again, I will first, it's up to you. You can make use of equation 3 or equation 4 to express one of that variable. It's either express y or express x. It's up to you. So for me, I will from equation 3, I will express x in terms of y. Okay, in terms of y. So I will rearrange this one, wherein 4 will go negative on the other side. So negative 4y, divide that 1 by 5 so that I will separate x. So 4 will go, negative 4y will go there, divided by 5, divide both sides by 5. So you will have your equation here, which is x equals negative 4y over 5. That is a new form. It is still equation 3, but a new form of equation 3. So let's call that one as equation 3a. So substitute that equation 3a in your resulting equation 4. So if I will do that, your x will become negative 4y over 5. So 25 times negative 4y over 5, and that is still 18 minus 10 equals 0. So if I will manipulate this one, 25, and that is divided by 5. Okay, 25 times 4 divided by 5, so actually you can cancel there 5 and 5. 5 times negative 4 is negative 20y. And plus 18y equals, okay, transfer this on the other side, that will become positive 10. So now you have a single equation which is in terms of single variable. So you can solve that one right away. So manipulate this one, combine, this will be negative 2y, that's still 10. Divide both sides by negative 2, you will have here y, but 10 divided by negative 2 is negative 5. Okay, that is only y. What else? We need to solve x and z. So go back. Since we already know one, you can go back now in any of that and solve for the other, but be wise. Okay? If you say, I will choose equation 1, substitute there y, there are two unknowns, so you cannot solve x and z at the same time. So if I were you, I will go backwards. Okay? You have your equation 3a, isn't it? You have y, substitute, you will be having x. So from equation 3a, your y is negative 5, change that one to negative 5. So actually 5 and 5 cancels, negative will make this negative 4 positive. So x is positive 4. Okay, you have now x and y. You can choose any of that to solve. You can choose any of these. But actually, if I were you, equation 1a is has z separated, isn't it? So you can make use of that one right away. So x is positive 4 and then y is negative 5. Calculate this one. 6 times 4 is 24. 4 times 5 is 20, but that is negative. So 24 minus 20 is 4. Minus 3 again, this is positive 1. Okay? You have now the three values. Again, all you need to do is check to make your answer 100% correct. So again, I showed you the three checking, but it's up to you. You can choose one. It's up to you. You can choose one. Let's say equation 1. Substitute x, y, and z. X is 4, y is negative 5, z is 1, positive 1, but that is originally minus. Equals 3. So calculate. Again, 24, 20 minus 1. 24 minus 20 is 4, minus 1 is positive 3. Yes. And you can check the rest. Okay. So that's it. That is substitution. Expressing a single variable in terms of the other, substituting that one to the other equations. Okay. So let's go to the second, which is elimination by elimination. So solution by elimination. So using a pair of equations from the system, eliminate one variable to reduce the number of unknowns by addition or subtraction. That's why we discussed that one on operations of polynomials, addition and subtraction of equations or polynomials. Okay, repeat the process until one unknown will be solved, then determine the others. Okay, so what are we going to do? If in substitution we are going to rearrange and then substitute that single variable, the equivalent of that single variable to the other equation, here, okay, we are going to take the equation from the system pair by pair, so by twos. And what we are going to do is eliminate one variable. And then if we will eliminate one variable, that will reduce us, okay, up to the number of unknowns, up to the time that you will reach only one unknown, and we will be solving that one unknown, and just like in your substitution, go back to solve for the rest. Okay, so we will be solving the same problem so that we will verify, and that should always be the same. Okay, so the same, this is your example number 1 in your substitution, but we will apply here elimination. If you say elimination, we will choose by pair and then eliminate one variable. Okay, so by addition or subtraction. So there is no other pair. This is only 2, so that is the pair, isn't it? So if I will try to subtract equation 2 from equation 1, I will be eliminating t. Why? You have there 2t, 2t. They are exactly the same. So if I will subtract this equation 2 from equation 1, okay, that is what I am going to do. This is your equation 1, that is your equation 2, but I will be subtracting that one. So 2t and 2t actually cancels, so your t is eliminated. Okay, that is why we call it elimination. And then if you will subtract, okay, s from 3s, so 3s minus s will be 2s, 7 minus 1. Okay, so we discussed this one in your addition and subtraction of your polynomials. If you are adding and subtracting, you can only add and subtract similar terms. So let's say there are difference in these variables. All you need to do is rearrange that one. If there is no similarity on the other side, then that will be there alone on the column. But since all of them has t and s and constant, then that is already there arranged itself. Okay, so now, okay, again, 3s minus s is 2s, 7 minus 1 is 6. Solve for s, so divide both sides by 2. You will have here s, 6 divided by 2 is positive 3. Is that our s a while ago? By elimination, yes, that is 3. Okay, now you already have one, so just like substitution, go back and then solve for the rest. So for me, you can choose equation 2 and equation 1. Okay, I will choose, let's say, equation 1. I want to use equation 1. So 2t plus 3, your s is 3, equals 7. So manipulate that one. Okay, manipulate that one. This is 3 times 3 is positive, is 9. That will go negative on the other side. So 2t will be there. Divide both sides by 2. You will have t. And that is 7 minus 9 is negative 2. That is divided by 2 also, which is negative 1. So isn't it that is our answer a while ago? Negative 1 and 3. So if you will do the same, okay, checking, you will apply checking, that will still be the same. Okay, that will still be correct. Let's solve your your problem number 2, also using this time elimination. Okay, this time we will be using elimination. Okay, so this is the challenge. But actually, if I were you, if that is just pair of two equation, the system is only 2 equation. The best there is substitution. Okay, you can make use of elimination, it's up to you. But if you have now more than more than one or two, I think, especially if they are, let's say, if this is three variable, that will make it a little bit complicated for substitution. Okay, I tell you that. So you will try to solve other equations with three equations, three unknowns in each of that equation. You will not be having a simple solution as what we have here. Okay, so let's try to solve that one by elimination. So again, by elimination, choose pair by pair, and then eliminate. Decide what variable to eliminate. Okay, so here I will try to pair. Okay, what will I do? I will pair equation 2 and equation 1. Get this pair. Okay, so what will I eliminate? So if I will decide, for me to decide again, if I will get this pair, I will eliminate z. Okay, you can eliminate any of these actually, but okay, if I will eliminate z, that will give us equation of x and y only. And you have equation 3 as equation of x and y only. So you reduce right away your variables. Let's say originally you have here x, y, z also in equation 3. Okay, let's say okay, originally you have this as x, y, and z variable. So it means if I will eliminate from pair equation 1 and equation 2, I will eliminate z. Then your equation 3 still has z. So what will I do? I will pair 3 with any of that again. It's either I can pair 3 with equation 2. So eliminate z again. So you from this pair, equation 1 and 2, I have equation of xy. From the equation 3 and 2, I will be having equation xy. If in equation 3 there is a z variable. But since there is none, so my solution is simple. All I need to do is eliminate z in your equation 1 and 2. So that is what I will be doing. But for me to eliminate, they will not cancel. So what will I do? I can play around with that. For them to be equal, it's either I will divide this by 4 or multiply that one by 4. But if I will be dividing this by 4, everything will be affected. Everything will be divided. That is rule of your algebra. If you will divide this side, you need to divide that side. So that will make this one fractions, which is you can do that, but that will be a little bit challenging to manipulate fractions, isn't it? You had that idea when we recalled your fraction. But instead of dividing, I'd rather multiply. So if I will multiply this one, this z here by 4, positive 4, so that they will be opposite, I will add this one, they will cancel, isn't it? So if I will multiply this one by 4, it means I need to multiply everything, the both sides. So what will I do is, I will add the product of 4 times equation 1. I will be multiplying equation 1, all entire equation 1 by 4. I will add that one to equation 2 for us to eliminate your z. Okay, so what will I do? I will first multiply that 4 with your equation 1. This will become 24x, that will be 16y, that will now be negative 4z, and that will be 12. Okay, and now, making use of equation 2, okay, copy that one, we are going to add that one. Why are we adding, not subtract? Because they are opposite signs. So if I will add, they will cancel. If they are the same sign, if I need to subtract, okay? If I will add this one, 24 plus x, that will be 25. 16 plus 2, that will be 18y. Now, 4z and negative 4z and positive 4z cancels, isn't it? Because we are adding that one. 12 plus negative 2, they will subtract as positive 10. So you have your equation 4, which is x and y. This is what I'm saying. A new equation, which is x and y only. And if you try to look at equation 3, that's good because that is only x and y. Okay, so use that one as another pair for equation 4. But let's say again, as I'm explaining a while ago, if this has z, then you cannot just use that one right away. You need first to choose another pair and eliminate z, and then that will end up xy. But it so happened that we only have their x and y, so I can just pair that one right away with your equation 4 for us to eliminate another variable. Okay, again, the process of elimination, pair by pair, eliminate one variable up to ending up one unknown, and then solve for one unknown, go back and solve for the others. Okay, so what will I do? Pair equation 3 with your resulting equation 4. So what will I eliminate? It's up to you. You can eliminate y, or you can eliminate x. It's up to you. But look at this. What number will I multiply with y for that to be 18? Think of a number, isn't it? That is 4.5, but that will make this one that will make this one fraction or decimal. So it's either I just multiply 5 with your 5, so that will be 25, isn't it? So multiply totally your equation 3 by 5. But again, let's say there is no simple as that number to be multiplied. Let's say even if I think of another number to multiply with 5, I cannot end up with 25x. Let's say that is the case. So what will I do? I will just interchange their number. Let's say multiply 4 with 18, multiply 18 with 4, they will make it the same. Okay? So multiply the two equations with a certain number so that they will be the same. But it so happens that if I will just choose x, multiply that 5 by 5, you will have 25 right away. So that is what I'm going to do. Subtract that 5 times equation 3. I will be multiplying this and subtract that 1 from your equation 4. Okay. So first is copy your equation 4. Copy that 1. And then multiply your equation 3 with 5 and then subtract that 1. Okay. So multiply this 1 by 5, 25. We will subtract that 1 since they are the same variable. But if you do not want to make your subtraction, what you are going to do is multiply negative 5 so that you will add. Okay, 5 times 5 is 25, 5 times 4 is 20, 5 times 0 is still 0. Okay, subtract, x and x cancels, but 18 minus 20y will be negative 2y, 10 minus 0 is still 10, divide both sides by negative 2, you will have y equals negative 5. Is that our answer for y using substitution? Yes, negative 5. Okay, now you already have 1. Go back and solve for the rest for x and z. So what will I do? Okay, you can use equation 3 or equation 4. It's up to you. Since these are the variable that has x and y, you have y, you can solve x. You have y, you can solve x. So for me, I will solve using equation 3. So substitute that negative 5 in your y. So you have there 5x plus 4 times negative 5 equals 0. This will be negative 20. That will go positive on the other side. Divide both sides by 5. You will have x equals 4. Okay. And then what else? We will be solving z. So what equation do you want? You cannot use equation 3. You cannot use equation 4. You can only use equation 2 and 1. So it's up to you. I will be using equation 1. So 6 times x is 4, isn't it? 4 times y, which is negative 5. And z is the unknown. So minus z equals 3. Manipulate. 24, and that is negative 20. Okay, z, I will put that one on the other side to make it positive. 3 will go together here as negative. Okay, so z is 24, negative 20, and that will go minus on the other side, which is negative 3. So you will calculate this one. 24 minus 20 is 3 minus 4 minus 3 is 1. So is that the same answer? 4, negative 5, 1. For negative 5, 1. So yes, so if you will try to check that one again by any of these equations, that will still be correct. Okay, so that is elimination and substitution. Solving your what do you call this one? Solving your system of linear equation or linear equations. Okay, if you have any question, comment that one. But before that, before I will end this video, I want us to discuss first this second. We have one more unit after this unit 4, but that will be a separate video for this video not to be too long. Okay, so unit 4. Okay, what is the topic here? Factoring. Okay, we will discuss factoring before we will go to solutions of quadratic. That is very, very important. Okay, so in this unit, you will be familiarizing yourself with the special products. Okay, factor polynomial by inspection, factor polynomials by trial and error. So special products. What is special products? These are actually products of binomial. Okay, these are products of binomial. Wherein, if we say a plus b, okay, that is any term. A plus b, which are squared, that quantity is squared. That means you are going to multiply itself by itself, isn't it? If I will try to do that, that will be a squared, that will be ab, that will be ba, or that is still ab, positive ab, and that will be positive b squared. So simplifying this one, this will combine, that will be negative, that will be positive 2ab, a squared plus 2ab plus b squared. So that there is a pattern there wherein it says there that if you are just raising itself, a binomial which is a binomial added which is raised to 2 or which is squared will just be a squared plus twice the product of a and b, that is the meaning of your 2ab, plus your b squared. Okay, if that is a minus, if that between is a minus, if I will do that, okay, that is the same as this, it is multiplied to itself. If I will multiply a and a will be a squared, a and negative b will be negative ab, negative b and a is negative still ab, negative b and negative b will be positive b. So simplifying, that will be negative 2ab. So that is the only difference here. If your binomial which is squared is positive between, that is plus 2ab. If that is minus, that is just minus 2ab. Okay, these are special products. We call this one the perfect squares. Because later on in factoring, if you will encounter such this form, you do not need to have a problem with that because you know that that is a plus b times a plus b, or a plus b quantity squared. If you will encounter this form, you know that right away that the factor of that is, okay, by the way, what is factoring? In product, we are going to combine into these factors into a single. Okay? But in factoring, we will try to separate this single into factors. That is factoring. So if you will encounter these forms, perfect square forms, you can have this as their factor right away. Okay. We have another special product, which is your sum in difference. What if, okay, a plus b is multiplied with your a minus b? They are different signs, so they are not square. They do not belong to a perfect square. Okay, if you'll try to do that, a times a is a squared, a times negative b is negative ab, b times a is positive ab, and then b times negative b is negative b squared. So simplify that one, ab and positive ab, negative and that positive will cancel out, so this will be eliminated from your equation. So you are only left with a squared minus b squared. So that is your sum in difference. If you are multiplying a binomial which is the same, but they only differ on the sign between them, the product of that is just squaring your first number and then minus the square of the second number. Okay, a sum in difference of binomial. This is perfect square of binomial. Okay, we will only focus on binomial. You have actually a lot of topic in algebra, but we will only choose. Okay, we will only discuss the binomial since that is what we will be using in your quadratic equation. If you say quadratic, your equation is just second degree. If you say second degree, that is just raised to 2. Okay, but actually you have also a square of trinomial. If you say trinomial, 3 terms which are multiplied to itself. Okay, but that will be actually almost the same as this, but will be a longer solution. So maybe if you have time, you can read of that, but since again we do not have much time, we will only be discussing those that are important, which are actually your foundations, and the rest will be the same, will be the same concept as your foundation. Okay, so these are the special products that we will be needing in your factoring. So first is factoring by inspection. If you say inspection, that is now when you will be by merely looking at the problem, you can decide if that is a perfect square or if that is a sum in difference, or actually you can just see there the similarity and bring that outside. Okay, so by inspection, all you need to do is inspect. Okay, so factor your equation 1. So look at this first. You might be thinking here as actually your sum in difference. It could be. But first, by merely looking at your equations, there are similarity, isn't it? That is the very first thing that you will be doing in factoring. Look at all the terms. If there are similarity, bring that first outside before worrying about these special products. Okay. So first, if you will try to look here, 4x4, 16x squared. So there is a similarity in all of that, isn't it? 4. And 16 is divisible by 4, so I can bring outside. Okay, if we say factor, bring that outside, since that is the similarity. So bring outside your 4. So what happens? What will be left will be x4 and minus 4x squared. But in x, there is a similarity. This has 4, that has 2. So I can also bring outside your x squared. So I will be bringing outside 4x squared. So 4x squared is outside. So what will be left inside? That is inside, enclose that one. Okay, enclose that one. What will be left here? If I will bring out 4x squared, there will be x squared left. Here, x squared is already there, but you only brought out 4, so what will be left is 4. Okay, so that's it. That could be your answer. Okay, that could be your answer. But looking here at x squared minus 4, isn't it? Okay, making use of your sum indifference. X has a square root, so that could be a squared. 4 has a square root, yes, which is 2. That could be your b squared, and that is minus in between, so that is just sum indifference. Okay, that is just sum indifference. So the factor of that is a plus b times a minus b. So what is your a? Get the square root of x squared, which is x. What is b? Get the square root of 4, which is 2. So you copy your 4x squared because nothing will happen there. Apply your sum indifference. Okay, that will be x plus 2 and x minus 2. A again is the square root of that. B is the square root of that. So square root of x squared is x. Square root of 4 is 2. So x plus 2, x minus 2. You have now figured out the factors. Okay, if you are not sure of that, multiply all of them. That should go back there. Okay, so that is how we will check your factoring. Multiply back, that should go back there. But that is now your task. You can check that one. Okay. Second, here, if you'll try to look here, is there a similarity first in all of that? No, there is no x in all of that, so I cannot bring out any of the x. There is no certain number that can divide all of them, so I cannot factor out any. But if you'll try to look here, they're all plus. 4x squared has a square root, isn't it? Yes. 9 has a square root. Yes. So maybe you are now given the idea of using your perfect square, and that is a plus. They are all positive, so that could be your sum in your perfect square. So if you'll try to recall here, okay, let's say 4x squared is our a squared. Get the square root of that, your a will be 2x, isn't it? Get the square root, b squared will be your 9. Get the square root of that, b is 3. You need to check the between. Before applying, you do not just decide on applying everything by merely looking at that, applying right away your special products, okay? Don't do that. You need to check all of the terms. This is a squared, that is b squared. So you have a and b. You need to check if that is, isn't it? If you'll try to go back, that should be 2ab. Twice the product of a and b. You need to check that one. So if a and b is 2x and 3, let's check your 2ab. 2 times your a times your b. 2 times 2 is 4 times 3 is 12. 12x. Is that the same as that between? Yes, positive 12x. So okay, you can now make use of your perfect square, which is the sum. So I will be using this. So we satisfied that this is true, isn't it? That is true in this function. So the factor of that is just a plus b, the quantity squared, or a plus b times a plus b. So what is your a? 2x plus b, which is 3. So 2x plus 3 times 2x plus 3, or that is 2x plus 3 raised to 2. Okay. So we have one more example. Factor 9s squared minus 3st plus 25t squared. So again, this is minus, so maybe that is the difference of the perfect square. So let's again say a squared is 9s squared. So get the square root, that will a will be 3s. 25t squared is your b squared. So get the square root, b is 5t. You need to check again between. Okay, you need to check your between. You need to check there your between. Okay, so if you will try to do that, 2ab, again, isn't it? That is your perfect square. Your between is minus. So you need to check if your 2ab is the number there. Okay? So again, check your 2ab. 2 times your a, which is 3s, times b, which is your 5t. So 2 times 3 is 6 times 5 is 30 st. 30 st? Is that 30 st? Negative 30 st? Yes. So we can make use of this one, your perfect square of the difference. So all you need to do is a minus b the quantity squared. A minus b the quantity squared, or a minus b times a minus b. Okay, that is by inspection using your special products. Okay, one more. One more topic for this. Okay, by trial and error. Okay, so when do we use your trial and error? If you cannot just solve that one by inspection, okay, if you cannot just solve that one by inspection, this is what you're going to do, your trial and error, okay. So if polynomial doesn't belong to any of these special products, so if you cannot see the right away special product, then you cannot use that one. Then the factors can be found by assuming factors and verifying it by multiplication. That's why we call it trial and error, because if you cannot do a special product form, all you need to do is now assume, okay. Assume a factor and verify that one by multiplication. Check that one. If your assumption is correct, check that one by multiplying. That should go back to the problem. Okay? But if not, then that is an error. So you need to try again. That's why it's called trial and error. Okay, in assuming, okay, so this is the pointer in assuming, so that you will not be having a lot of trouble there. It is better to consider the factors of the extreme terms. Let's say extreme terms are the a squared and the b squared. Okay, that is your pointer there. Try to figure out the factors of your a squared and your b squared, and those are the values that you are going to use in your assumption. Okay, that is where you will be finding the correct answer. So let's have this example number 1. Did we answer this one before? I guess not. So let's try to answer that here. Okay, so extreme terms. So that is your extreme terms. If that is not arranged in a decreasing, you need to arrange that one. Okay, that is also an important part. Let's say this is disarranged. It is not arranged in a decreasing manner. So what you're going to do is arrange first in a decreasing manner. Okay, highest degree going to the constant. So get the extreme, x squared. What is the factor of that? That is x and x, isn't it? That there is no other factor, that is the only factor. 15, negative 15, consider the sign. What is a factor of negative 15? Okay, by the way, by merely looking at that negative 15, that means negative b, there is no such special product that has a negative b. So you cannot use that one, even if your sum indifference. Okay, maybe your sum indifference, but in sum indifference, that is obvious since you only have there number minus number squared. Isn't it? But in our problem here, you have here 3, and that is negative. So that is not a perfect square, that is not a sum indifference. So again, apply the trial and error. First, know the factors of your extreme, your a squared and your b squared. So x again is just x and x. Negative 15, what are the factors of this? It could be positive 1, negative 15, or this could be reversed into negative 15, positive 1. Isn't it? What else? 3 times negative 5 or negative 3 times 5. So it's up to you. Now, just get this pair. This could be your A, that could be your B. Or this could be your A, that could be your B. So what will I do? Okay, A plus 3. Let's start with this one first. X and positive 1. And then multiply to x and negative 15. So that is the factor that I assumed. That's why we call it trial and error. I will first try this one. Try. Okay. X and 1, and then x and negative 15. Multiply that one. X and x will be x squared. That will be negative 15x. That will be positive x. That will be negative 15. Simplify. X squared. Negative 15 plus 1 is negative 14. Negative 15. So if you will try to go back, isn't it? That is wrong. Why? Yes, correct. The extreme values are correct because, of course, we use the factor. That is the good thing. If you are using your factors, you will end up correct with your extreme values. Your only problem is your middle. But you need to check your middle. Negative 14, that is the result of our trial. But that is negative 2. So that is wrong. Okay, that's wrong. You need to try again. Okay, maybe this is to be partner with that. So x and 3, x plus 3, x and negative 5, so x minus 5. Multiply that one, x squared, negative 5, negative positive 3x, negative 5x, negative 15. Combine, x squared, negative 15 will be the same, but this will be negative 2. Is that the same as that? Yes, therefore this is the factor. Okay, so that is your trial and error. Let's have one more. Okay, before I will end this discussion. 6x squared minus 17x plus 2. Okay, so there is no other way again to pinpoint if this is a sum indifference. That is not sum indifference, but you cannot figure that that is perfect square. Let's say that is perfect square. Let's try to check. So if that is a squared, the a of that is, okay, let's try you are using your inspection before we will do trial and error, okay? That is your a squared, so the a of that is square root of 6. So that is actually already unapplicable, because if you try to get the square of this, 6 doesn't have a perfect square, isn't it? And so with 12, there is no perfect square for 12. There's no square root for 12 and 6. So you cannot use inspection right away there. So your only choice is trial and error. So let's say, find the factors of your x squared. That is 6 times x, yes. Or it could be 2x times 3x. That could still be the same, isn't it? Okay, how about the factor of 12? That is positive. Okay, this is your pointer here. Okay, a positive could be a product of negative and negative, or a positive and negative. But your pointer here, for you to consider if that is a product of negative negative or positive positive, is that since this is plus, isn't it? Your pointer is that look at the middle term. That is negative, so maybe I need the factor of that, which is the negative factors. You can actually try your positive factors, but I am sure that will not give you the answer. Why? That we need to end up with a negative middle term. In here, okay, no problem, because there's no other choice. You cannot have there the factor for negative 15 is always a plus and minus. But in here, it could be a positive positive or a negative negative. But since that is negative, use the negative negative. Okay, so again, this factoring, if you are now used to that, by merely looking at this, you can actually assume the correct answer. Okay, if you are used to that. But of course, in the meantime, since you are still starting, you need really to do a lot of trial and error here. Okay. So, okay, so let's try. Again, I will use the negative factors. So what is the factor of 12? It could be negative 1 and negative 12. What else? Negative 2 and negative 6. What else? Negative 3 and negative 4. So there are a lot. So it means there are a lot of combinations that we will be doing. But again, if you are used to this, by means of your instinct, you can choose the partner right away. Okay, so let's say, since let's forget that I already know how to figure out right away the answer. But let's say, okay, let me first pair your this and your this one and your here. Okay, let's say I will first pair this one. Okay, I will not be showing you all of the possibility. I will just only show you, okay, some. So let's say I will pair this x and 6x with your negative 2, negative 6. So x and minus 2, 6x minus 6. Check that one, 6x squared. That will be negative 6x. That will be negative 12x, isn't it? That will be positive 12. So combine, 6x and 12 will be still the same. This will combine as negative 18. Is that negative 18? No. Even if it is close, no, still. So that is not the factor. Okay, now I will show you the correct factor. Okay, that is your actually 2x, 3x, and then your negative 3, negative 4. Okay, if you will try to pair that one, 2x and negative 3. Okay, so 2x minus 3. 3x minus 4. Multiply. This will be 6x squared. That will be negative. 2 times 4 is negative 8. That will be negative 9. So 9 times 3 is negative 9x. That will be positive 12. So combine. So again, 6x and 12 will be still the same. Negative 9 and negative 8 will be negative 17. Is that the middle? Yes. Okay, therefore our factor is 2x minus 3 and 3x minus 4. Okay, that is trial and error and your inspection using your special product. So factoring. That is your unit 4. Okay, so again, you have your unit 5, your solutions on quadratic equation, but I will separate that one since your video is already too long. Okay, so if you have a comment, just comment below the video, or you will ask that one in our next live